So what we'll do is we'll finish the 3B notes. I'm not going to do, here, let me go find them for you. I've got them locked and loaded back behind here. So in my 4th hour yesterday, we did get one farther than you guys. We did do example 3, so I'm just going to show you it. And we'll go start in with example 4 so they don't listen to the whole one. But remember, our goal is to find all numerical values of x, element of the real numbers, so that when I plug them into this now function of x, it's a series, a power series, I get convergence. So we ran through this one with the ratio test like I taught you how to do. And what happened at the end of it is we ended up with our limit being 1 over n plus 1 as n approaches infinity. And we're very aware that that equals 0, correct? So my goal was to find all values of x such that its absolute value times 0 is less than 1. And this happens for all x, right? So we would say that its radius of convergence is infinity. Its interval of convergence is negative infinity to positive infinity. However, I would challenge you to tell me what this actually is as I start to write it out. And I'll change this to a 0 just to make it more clear. But when I put in a 0, I get x to the 0 over 0 factorial. When I put in a 1, I get x to the first over 1 factorial. When I put a 2 in, I get x to the second over 2 factorial. When I put in a 3, I get x to the third over 3 factorial, etc., etc., etc. That should be becoming recognizable to you, and it needs to become recognizable to you by the end of next week when we test. What is that? That's E, and in that video I showed you yesterday, that guy showed very clearly that e to the x, even when he went out to e to the first, second, third, he got the exact value as what we obtain when plugging it into that polynomial. So this actually is e to the x, and it has convergence for all x, so that if we want to know what e to the fifth is, I merely need to do 1 plus 5 squared over 2 factorial. And if I go to infinity, it will converge or be equal to the actual value of e to the fifth. All right, so the next one up. And I do need to talk quite a bit today, so I apologize for that, but you guys are my reason because of science, so I blame it on you. All right. Here we go. And there's 2 science classes going, correct? I think it's anatomy and physics, and pretty much all you people are in calculus 2 or BC. All right, so here's my next one. I have now a power series that has an alternator in it. Remember the distinction between a power series and our series from the first half of the chapters. We now have this x in there. They're now functions. So if I have some function x that I'm saying expands into this power series, I want to know the values of x such that there's convergence, where they're actually equal, right? Hey, put that screen down there. Thank you. Thank you. All right, so I am going to run what test on this one? Which one's the big hitter, did I say? The ratio test is the big one. That's one you'll use most of the time. Some of the simpler ones lend themselves to the geometric series test, but most are ratio. So remember what we do is we're going to take the limit as our count goes to infinity. What happens when you do this with an alternator, because the ratio test has absolute values on it, it kills the alternator. So you don't even need to include it. That should make obvious sense to you, right? So with the alternating series, you don't need to put it in here because the absolute value makes it obsolete anyway. So remember, I'm doing x plus 1 to the n plus first. My marker's being weird. Sorry about that. All over 2 to the n plus first. And our ratio test says we divide by the previous term, which means in this scenario I'd multiply by my reciprocal. So 2 to the n on the top, and on the bottom, x plus 1 to the n. Remember our goal and our reason for choosing this ratio test. We're trying to find my domain, which would be all x such that my ratio test causes convergence. So remember, it's a little different than when we were determining convergence or divergence. We're forcing convergence by setting it less than 1. And we do it the way we did last in the first part of the chapter. So I'm going to go quite quickly on this if you don't mind. Is that fair enough? What's going to be left when I simplify everything? On the top, a what? Just an x, right? Plus 1. And on the bottom, what? just a 2. All counting mechanism parts have disappeared, so I will rewrite that. But remember I told you yesterday that anything not involving the count is actually a constant. And you might say x isn't a constant. It is once I plug it into the function. So all counting mechanism attached parts come out front in their absolute value. So I'd have the absolute value of x plus 1 over the absolute value of 2, and essentially all the rest of it would be 1 because it's all disappeared. And I want to force that to be less than 1. Well, the limit of a constant is itself. So basically this is just 1. So I'm faced with the absolute value of x plus 1 being over 2 being less than 1. And we did this yesterday, so it's going to get a little, I'm going to go a little faster through the mechanics. It's the end part that I really want to focus on. Now, there's a couple ways for you to think about this. I'm going to be honest, in my years of teaching this now, most kids go to what they were first taught, which is to solve an inequality with a less than. I squeeze it between the positive and the negative, and because you're comfortable with that, that's probably what you'll choose to do. But I'll tell you the way you're really supposed to think about this is if you go up to the top here, what is this guy's center? Because it says x plus 1. What is the center for my series? -1. It's x minus c. So really, this is centered at -1. And once we get it down to right here, this is x minus c, and I want that distance to be less than the radius. Really what this is saying is that I have to be within 2 units of the center, and my center is -1. That's how you're supposed to think about it. You're supposed to be within 2 units of -1. Where would that put you? -3 and what? 1. That's the thought you're supposed to use. Most kids, though, like to revert to solving this algebraic inequality, and it works nicely. So, but really, you're supposed to be thinking about this as a center, and the center's at -1. Do we get why it's -1? Because you subtract your center. And this gives me my radius. That's really how you should think about it. Now, you have to be careful, like I told you yesterday. So I'm back up here. I know my center is -1. I know my radius of convergence is 2. That's what, right here gives me my r. My interval of convergence, remember, I went through it really quickly yesterday because I showed that long video. I said, be careful with it. Do you remember what I said to be careful about? Be careful. What'd you say? That, yeah, knowing whether actually on the ends of the interval is there convergence or divergence, and there's a couple that are so simple you'll know, but most of them require plugging in more deep thought than what went on in here. You actually have to test them. So this one I'll do very thoroughly. A couple of them I think I'll test sloppily just to move along. But what do I test them in? Because that's sometimes an issue. Kids will say, okay, well, what do I talk about? Where do I test them? What do I test it in? The original series as input for x. Yes. So I actually now revert to my tests from the last part of our series unit. I'm going to test, my left endpoint was a -1, correct? -3. All right, so I'm going to test -3 in for x. So I go put it in here, and the result is I get a -2 to the n over 2 to the n. I need to know from the first part of my chapter whether this converges or diverges. What I would suggest you do, you have a couple options. I'm going to just open up the floor here. What's an option for simplifying that? Multiply the top. Yeah, because it's totally true that if you have a product to a power, you can write it as the product separate to the power, and you can reverse it. So it's totally true that I could call this 2 to the n on the top. Agreed? Because I could just multiply them and say that's 2 to the n over 2 to the n, and it's a sum. And notice I've been sloppy. I'm leaving my count off, and I shouldn't. You guys know that. I am going to get a little sloppy just due to time constraints. I got a lot to get through. This is actually the series of 1, which is 1 plus 1 plus 1 plus 1 plus 1. What does it do? Diverges. If you had to give a reason, you would say by the nth term test, right? Its limit is not 0. You don't have to tell me what it is. It's actually infinity, but the limit is not 0, right? So we have divergence on -3. That tells me don't include -3 in my domain. Next thing I'd have to do is test, what was the other end of my interval? 1. Now look at that. Again, I'll get a little sloppy here. That's going to give me 2 to the n over 2 to the n, which is going to cancel. So I'll be looking at the series of -1 to the n, which means it's going to go 1 plus -1 plus 1 plus -1 plus, what do we say that does? That oscillates. So what does it do? Diverges by oscillation. So both endpoints failed. Do they always fail? No. And again, I told you yesterday for multiple choice to test this concept, what they'll do is put so it won't even matter that you could do all the work leading up to it. On one of the questions, you'll be asked generally to just find the interval of convergence, and this is for you being able to get it down to the inequality will be of no help to you because all of these options will be sitting there. Yeah. That's what I'll talk about that later. The question is how thorough do you have to be about writing this? And I told my 4th hour yesterday, I said, I'm going to go look at some where they've occurred in the past. And actually in 2016 they had one, and it converged by the alternating series test, and that's all College Board had on the scoring rubric. It says converges at 2 due to the alternating series test. It didn't say because the limit as n approaches, but I never know. I would be thorough on that on your worksheet. If you're like, oh, I know this is the divergent harmonic because blah, 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 you can maybe cut a little of that out. But I would err on the safe side because honestly, sometimes from year to year, the points are different. So we'll run through this top one and not the bottom one. Fair enough? So it says considered this function that I've got a power series written for, and I want to decide where are they equal. That gives me my domain for my function. Where they're not equal, we say it diverges away from the actual function. I think you get that. So what test would I use on this one? What test? Ratio. Let's run through it really quickly. The limit as n approaches infinity of x to the absolute value, put in an n plus 1 for all n, and I'd have n plus 1 over 3 to the n plus 1 over n plus 1 quantity cubed, right? And then I divide it by the previous one, multiply by the reciprocal, 3 to the n cubed. And you might say, she's going fast. I know. I have to. I have a certain spot I want to get to. I want to find all x such that that is less than 1. And catch me if I'm going too fast and I make a mistake. I'll clean this guy up. My x will be left on the top. My 3 will be left on the bottom, correct? I'll have 1, 3 down here. Picture taking the limit of the non-constant stuff, meaning the limit of the expressions that have the count in them. So really what I'm saying is the limit of n cubed over n plus 1 quantity cubed as n goes to the infinity. What would that limit be? 1, because I have the coefficients of n cubed on both of them. So remember the non-count comes out front. Absolute value of x needs to be considered. Absolute value of 3 is 3. The rest of this stuff, if I were to write it nice, which I'm not for time, I'd have an n cubed, blah, 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 and an n cubed. That limit goes to 1. So I have this. So once again, I'm stuck with this absolute value. I didn't make a mistake, did I? You guys aren't saying anything, so I'm feeling good. I went really fast. But again, I'm going to have x smashed between 3 and -3. It's the testing of the endpoints I want to really drill home today. So let's go take a look at what happens. When I put in a 3 for x, I'll be taking the sum of 3 to the n plus 1 over 3 to the n, right, times n cubed. Where is there a 3 left? Because we always go to the where there's the most of them and then we clean it up. So where's there 3 left, obviously? On the top. You should immediately know whether this converges or diverges based on our last unit, right? That is a convergent p-series. And then Chris asked that question, how much do I have to write? I know you know why. I made you write a whole study guide on it, and I made you do very well on a test, so I'm fine with you just saying it's a convergent p-series. But if it's on the AP exam, I'd err on the safe side and say with p greater than 3, greater than what? 1, right? Just err on that safe side. But that's a convergent p-series. So I know I have convergence at positive 3. Are you okay with that? Am I going too fast? Are you good, Rach? All right, now what would I do? I'd test negative 3. So in a similar fashion, I'll just go over here. I'd have negative 3 to the n plus 1 over 3 to the n cubed, sum, n goes from 1 to infinity. Now what's going to happen with that? What do you think? Go clean it up yourself to see what happens with it. I would maybe rewrite this guy. Again, this is where it gets a little tricky, so I do want you to make sure you can think this one out, because this is going to need a little rewrite for you, I think. I would write it as negative 3 to the n times negative 3, and again, I dropped the sum, which is pretty illegal, but just for time purposes. Look at how I rewrote it right here in blue. Everybody look. Now I can condense this guy. What can I call the negative 3 to the n over 3 to the n? Negative 1 to the n. Agreed? Now I have an alternating series, right? This would actually be negative 1 to the n when these are cleaned up. And I have a negative 3 over n cubed. And this is the sum as n goes from 1 to infinity. Well, remember, constants come out front and don't affect convergence. So the negative 3 really is going in front, and I have an alternating p-series. Convergence or divergence? Totally converges, right? It does. I know it doesn't need, it converges absolutely. It doesn't need the alternator in there, but that would be a negative 3 also with a beefy. We're going to skip the next one, and we are going to move along. All right? So moving right along here. I'm going to wait on this. I have some scoring guidelines in there from a test. I'm not quite sure why. So now we're going to do some new with a mix of repeat. I'm going to tell you that the first year I taught this, this is where I started this stuff. I had no 3B, and I had no 20-minute video with cool graphics. Why do you think I had to insert those things? This didn't go well. There was a lot of confusion about what kids were doing. They could do it because you follow the rules, right? They could do the ratio test. They just really didn't get quite what this series was and what the function was. And so I found this interval from negative 2 to 7. What is it? There was a huge confusion, and it was my fault. I went too fast, too far. So we just took a day and a half to slow her up. So a lot of this, I'm hoping you're going to go, yeah. That's my hope. So this is where I traditionally start. I say, here's a new thing, guys. It's called a power series. Note that it has X in it now. This is centered at 0. This has got the center moved. That caused some confusion when I said moving the center. They're like, what do you mean by that? Do you guys get what I'm talking about now? That should be very clear to you. All that does is shift it on over. You might say, well, what's happening to all the factorials? They're absorbed in the coefficients. When you write the polynomial, sometimes things cancel and you won't see those. So know that. A sub n is generating the coefficient. It isn't necessarily the coefficient. It's generating it. And then we talk about finding where there's convergence, because that's where we get our domain for that function. It can happen only at C. Well, that's not very exciting, right? That's our tangent line approximation. It converges for all x. That's awesome, because then we can actually use the polynomial instead of the series, and they're so user-friendly, right? Polynomials are great in calculus. They're easy to graph, derive, integrate. It's awesome. And sometimes they converge in a finite window, and that's what we've just been finding. All right, so and then I said, but you guys, you got to test the endpoints. Now, had I started with that a day and a half ago, do you understand why they were swimming? Kind of. Like, it wasn't good. So we'll go a little quicker. So example 1 says find the nth term power series. You shouldn't need to find it now. You should be able to write it. So go ahead and write that. Find the nth term. I want you to put this in brackets. The nth term also gets phrased as the general term, and that's actually how College Board states it. They'll say, write the first 4 terms and the general term of the power series. So let's go do that. We now know that e to the x converges for all x to its polynomial series. You shouldn't need to derive it. You should, again, think e to the 0 is 1, right? Plus its first derivative, which is 1 times x, plus its second derivative, which is also 1, x squared, over what? 2 factorial to counteract that second derivative of bring the 2 out front, and it cancels it off, so we should get that. That's not quite done. Plus x, usually I'll say the first 4 terms and the general term. So what we do is we ellipse our way. Note there's no alternator for e. That should make sense to you because it's generated by derivatives of e, and those are always positive, so that alternator should make sense. Then we do plus, and then we put what's called the general term. The general term has n in it, and when you plug n in, you get the nth term. What is the general term for this one? X to the n over n factorial, which you should be going, yeah, I get that because you made us watch it yesterday and we just did it 5 minutes ago and you're killing us. That's better than you being confused, so I'll kill you today. Then you go plus and you ellipse, 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 showing that you are doing an infinite series. That's the first 4 terms and the general term. I already told you and proved to you what the radius of convergence for this is. What is it? Infinity. What's the interval of convergence? Negative infinity to infinity, and that should be very clear and not going too fast. And we proved this already, so we can just write did and put an arrow back. You'll find it someplace in your notes where we did that. So moving along. All right, I would love to give you time to pause. Which one of these can you do in your head, A or B? Just because you get it now, because LaRue didn't go too fast. Can A be done in your head or B? Beacon. That's a geometric series. We know those converge only when the absolute value of r is less than 1. I can see it, right? So for letter B, because I really get it, and because I understand that it's geometric and I have to be purely less, here's my interval of convergence. Why don't I have to test the endpoints? You can see it. You're going to get 1 plus 1 plus 1 diverges. Nth term test, and you'll get 1, negative 1, 1, negative 1 diverges, oscillation. So that one's done. What's its center? 0. What's its radius? 3. I'm 3 away from 0 on both sides. It all looks good. That's done. This one I'd need to stop and I'd need to pause and do a little work. So what work would I do? We'll do it fairly quickly. Vito, what work will I do on this one? I'm like, I don't know. Yeah, sometimes you look at them and you go, you know what, I know that converges everywhere because the bottom's killing the top. I'd say on this one, we've got nth powers here. So like if this was a factorial on the bottom, I might be tempted to say this has convergence everywhere just because it looks good. But I'll take the limit as n approaches infinity of the absolute value, which kills the alternator, of x minus 5 to the n plus 1 over n plus 1 times 2. It looks so difficult, but in theory, it should really make sense to you. Do not show this to people not in here. They'd have no clue what's going on, but it's good stuff. N 2 to the n. And then on the bottom, I'd have my x minus 5 to the nth power. And what do I want to do? Like if I was writing this nicely, how should I really write it? I'd add a prefix for me. What would I put above that? Find all x such that. Yes, I would say I'm going to find all x such that, and I want to force this to be less than 1. If I'm being thorough on a test or an AP exam, I'd actually be super neat, but LaRue's stressed for time because of physics and such. So I want to get as much done as I can today. On the top of this would be an x minus 5. What would be on the bottom? What would be on the bottom? Help me out. just a 2. Now, can we in our heads just take the limit of the counting mechanism? Do you know what I mean when I'm saying that? Take the limit of the counting mechanism? Because it really means take the limit of n, and that's not what I'm doing. But anything with the counting mechanism in it. Stare at only the n stuff. What's its limit? So at 1. Yeah, it's n over n plus 1. So all non-counting mechanisms must come out front with absolute value attached, but 2's absolute value is 2. The whole rest, by the way, the whole rest of it is usually 1 or what? 0 or infinity, actually. And that's the when they only converge at the center, which is boring and isn't useful, so it never happens. So I'll revert to, it's either going to be 1 or what? 0 generally. I mean, sometimes they might throw a little 3 in here, so you have a 1/3 and you have a little more, but most of the time we get 1s and we get 0s, and it's some interval or it's everywhere. So that's what I want. I want absolute value of x minus 5 to be less than 2. Now let's talk about how you're supposed to think about this. What is the center? 5. And I want to be how many units from the center? 2. That's how you're supposed to think about it. I'm centering this at 5, and for convergence, I need to be within 2 of 5. And you're supposed to think, okay, 7 and 3. That's not what most kids do. They go revert to Algebra 1 and set up the inequality. You do you. I honestly think that's safer because it's what your comfort level is. But I am just going to go right here and say, I know I'll be between 3 and 7 because I need to be within 2 units of 5. All right? Now, technically, I'm beefy, wimpy, wimpy, beefy. I have no idea. So again, where do I go to determine that? That's where I want to slow down. Be very careful. Okay? I go up here and I test. I always like to test the top one. I don't know why. You'd think I go left to right, but I don't. I always test the right endpoint. It's kind of weird, but it's what I do. All right, let's talk about that. Can I just talk about it? Can we just look? You would have to write it down. But again, for the 10th time, physics is killing my time. All right, here we go. So this is supposed to be a 2-day notes that I'm cramming into one. On the top, I'd have 2 to the n, when I put in the 7, over 2 to the n. Agreed? It's going to cancel. Remember, the absolute value of the ratio test kills the alternator, but in the series, it's still there. So what I'm left with when I cancel those off, let's go, just because 4th hour, they're not going to be looking at me. I'd be left with this, which cancels with that. I have the alternating harmonic. Agreed? What does that do? Converges. But you'd have to say by what? Otherwise, you do have to at least say at a minimum by what? Alternating series test. Now, I would err on the safe side of saying the limit of, in the absence of the alternator, of 1 over n equals 0, therefore. But yeah, we totally have convergence on the right. So I do beefy with the 7. However, when I go to the left and I put in a 3, okay, I would have, I'm going to write that one down, -1, the alternator's still there. I would have a -2 to the n over n2 to the n. Let's discuss that. What do you think I would suggest you do to be safe? What do you think I'd suggest? I would take that -1, write it to the nth, times -1. Okay, this is what I would do. I'm going to go, oh man, I'm going to run into this guy's workspace because I don't need it for him. So what I'm telling you is I would just take a moment because it gets, if you start cutting corners, you'll get the endpoints wrong. I would disengage that from the n plus 1 because I have the -2 to the n right here, and then I have the n2 to the n. I'm going to leave the summation off, just out of sloppiness. But now these guys are to the same power. So what do these two make together? 2 to the n, which cancels with the 2 to the n on the bottom. This is not the alternating harmonic series. The alternator's gone, right? This is -1 times the what? Divergent harmonic. You guys are really good. Yeah, if I were to write this nice, it's a -1 times the sum as n goes from 1 to infinity, 1 over n. And any multiple of a convergence or divergence series has the same behavior. So that actually diverges on the left. That's the trickiest part of this. All right, so that was example 2. I think you're going to have to go ahead to get to example 3 because they're out of, is your packet stapled out of order? Yes, I think we can be done with this. Or do you feel confident with this type of test? I want you to guess at what's going to happen on letter D. Guess. Look at it. What do you think that does? Diverges everywhere, except at the center. What would be its radius? 0. What would be its interval of convergence? 0. Why do I say it will converge at the center? What happens when I put a 3 in? I get 0, which would be f of 0, so that will be fine. But D is nonsensical as far as a power series go because it's dumb. I might as well just do a tangent line for whatever the function was. Letter C, I'm probably going to have some interval, but we just did one like that. So we're going to move on. Okay, so it says we will now look at a special family. These should look super familiar because doesn't my Taylor series look identical to my Taylor polynomial? Right? Doesn't this look identical to your Taylor polynomial? What's the only difference? I'm going to infinity, right? So it's no longer a polynomial. It's a series. I no longer have to write approximate. I write equals, right? But the expansion's the same. What I want to caution you about, watch, go right here. We're on example 3. Good, we're cruising here. I should be able to, this is good. All right. So it says, find a Taylor series for e to the 5x. Here's what you cannot do. Don't write this down. Here's what you're going to be tempted to do. Because you remember me saying, don't write this, if you know e to the x's, which we do, and we're going to have it memorized so we don't have to create it, it's going to be one that we just know. Don't write this down. Plus ellipse n over n factorial plus ellipse. Okay, there it is. That's the Taylor series for E. Converges everywhere. We already know that. You cannot put a 5x in there. You might say, LaRude, we did last week. Look at there's something that makes that not legal here. I moved the center. Yeah. If you're going to move the center, you can't use a modification of one at a different center. And that one is centered where? 0. So be very, very careful with that. If this said centered at C equals 0, then I have a nice easy problem that I can just put a 5x in its function composition and I'm good to go. But if you move the center, derivatives change. Think about it. Think about the sine polynomial at 0. What sine of 0? 0. But if I recenter it at pi halves and start there, what sine of pi halves? 1. See how changing the center changes things in the polynomial. So you're going to have to do this from scratch. What do I mean by that? You're going to have to say this. You have this function, e to the 5x, right? That is going to be equal to some power series, correct? But remember, grassroots, this will be, I want you to write the model out. Remember how it starts. F of what? This is going back a couple days now. We haven't expanded one for a while, but it's back. F of, which is 2, yep, plus f prime at c times x minus c over 1 factorial plus f double prime. And if you don't write out the model, it doesn't trigger the process. So although it's a pain to write it out, I'm just going to go like that for now. Notice what it says though. First 4 non-zero terms. It doesn't say 4th degree, so watch that. And then it says and the general term. What's the general term again? What's the general term? That has the ends in it. All right, so I need to go off to the side and create all these coefficients. They're called the a sub n's, right? I will go create those by going over here and saying my function is e to the 5x. My function evaluated at 2 is e to the 10th. Then what will I do? Create the next coefficient. This is the successive derivatives. This makes them match at a point. Now I'm going to make sure the slopes at that point are the same. F prime of x is 5e to the 5x. In particular, at 2, the slope of my tangent line needs to be 5e to the 10th. So now I've got my function and my polynomial matching at the center, and they have the same slope at the center. Next is to make sure they have the same curvature there. So you see what all these successive derivatives are doing. I will go to f double prime. Now, this is what I'm going to suggest for you. Are you ready? You're going to be tempted to say it's e to the 5x times 25. I would suggest you don't condense things so that you can see your nth term better. I would suggest that you write it as 5 squared. It's the second derivative, and there were 2 5s. Do you see why I'm suggesting that? When we write the nth term, when you see like a 625, you maybe don't realize that that's 5 to the 4th and it's 5 to the 2n or something like that. So I would leave them beefy like this. In particular, at 2, f double prime of 2 is 5 squared e to the 10th. Now, anticipate what's going to happen when I do my third derivative. What am I going to get? 5 to the 3rd, e to the 10th. And my fourth derivative, 5 to the 4th, e to the 10th. So let's go replace those up here. F of 2 was e to the 10th. F prime of 2 is 5 e to the 10th times x minus 2. Sorry, I should have put my c in there. Why not? I put it in the f ofs. Look at, I mixed them all up here. This was a 2 and a 2. We're good though. Then I'd have plus, and there was no sign change, so I'll have no alternator in my nth term. It was 5 squared e to the 10th as my second derivative, and I have it times x minus my center. It looks complicated, but if you truly understand what you're doing, it's not bad. Am I done? Did I make a mistake? Oh, squared. Where's squared? Oh, squared. Thank you. Am I done? I've got 2 things left, and I have to write them correctly. I need the fourth non-zero term. I need the ellipse, general term, ellipse. Okay, so write the fourth one for me, or fourth general term, third degree. Notice they're different. So we'd have 5 cubed e to the 10th, x minus 2 to the 3rd over 3 factorial plus. Now I go ellipse plus. General term. What is my general term? In terms of n, it is 5 to the what? N. E to the 10th is constant throughout. X minus 2 to the what? N over what? Now, you really ought to tell me where you're starting your count. Because you're not writing it as a series and you're writing the nth term embedded in the expansion. If I'm going to write it at like that, where did I start my count? Usually it's 0 or 1. Where is mine started? 0, right? Because I want to have 5 to the 0, x minus 2 to the 0. I want only e to the 10th left here. I like it when you write this beneath it. It's not necessarily required, but it helps because sometimes it'll say, and then write the power series. So if this said, and then write the power series, I'd write this is the sum, n goes from 0 to infinity. Do you think that matters whether you put a 0 or a 1? Do you think that's a big deal? It actually is a huge deal. So now, if somebody says, I don't want to do that, I want to start at 1, guess what their general term would look like? It'd be kind of a pain to correct these on the AP test because you got to look at everything. Some kid might have said, I'm going to start my count at 1. In which case his general term changes. What would it become? 5 n minus 1 e to the 10th x minus 2 to the n minus 1. We call it adjusting the index to create a cleaner term. And usually 0 is cleaner than a 1 for these. So I like that. But anyway, moving right along, was that example 4? My goal was to get through I've got some more I want to get through. Why won't it turn the page? All right, we can cruise through this. Are you ready? Example 4. Hey, what does this look like? What is this? Your pages are out of order, I know. your packet is out of order, my smartboard's not. What is that guy up there? That's E. Correct? Now, it says to find f prime of x. I told you that the polynomials, if they are equal to their power expansions, all things hold. Their derivatives are the same. Their integrals are the same. Everything. I know what I'm going to get because that's e's expansion. And what's the derivative of e to the x? Watch it occur. Okay, here I go. The derivative of 1 is 0, but then I get 1 plus. Bring the 2 out front, cancel it with the 2 on the bottom, and I get an x. Plus, bring the 3 out front, cancel it with the 3 on the bottom, because the bottom has a 3 times 2 times 1. And what do I get? X squared over 2 factorial. And guess what? Take the third one, fourth one, doesn't matter, right? Blah, blah, blah. Do you recognize this? You ought to, right? This is e to the x again. And what's e to the z? What's the derivative going to be at 0 of the polynomial? You can see all these would cancel and you get a 1. And what is the derivative of e to the x at 0? E to the x. You see how the behavior's the same? Shouldn't surprise you either on example 5. And I'm able to go fast with you guys because I think we get it. So this guy, you should recognize him. That's e again. Now look at what it's saying. If I were to give a name to capital F, now I'm going to pause a little bit because notational fluency is huge. If I were to give capital F a one-word calculus name, what would I call it? Capital F is the what? Antiderivative. Exactly. Excellent. And it says to find the if you don't have notational fluency, one like this is incredibly difficult. But if you do, this is easy. It's just the antiderivative. They just want me to integrate this guy. Why are they giving me this? This is Carl. Well, how does Carl come into play? Same way he always has. Watch me go find my antiderivative. To find it, I'd integrate this guy with respect to x. What is the antiderivative of 1? X. What's the antiderivative of x? X squared over 2. What's the antiderivative of x squared? X cubed over 3, but I already had a 2 factorial, and really, what is that? 3 factorial, etc., etc., etc. Agreed? Now, technically, there's a plus c, but with these, we don't put them at the end. You can see why I can't get to the end. It's an infinite sum. Guess where we put it? We put it at the beginning. So really what we do with Kyle is we put him over here, but we still find him the same way. You get why tacking it on to the end is like, you can't tack something onto the end of some place that you can't get to. But I could put him at the start of an infinite. So Kyle actually comes out front, but I find him the same way. This is saying when you put in a 0 for x, you must get a 1 out. Well, when I put in a 0 for x, all of this tends towards 0. So who's Kyle? So look what I've got. The antiderivative holds all the stuff that held. If I asked Vito what's the antiderivative of e to the x, I'd hope he'd say e to the x, right? Well, its polynomial plays out exactly in the same fashion. So can somebody tell me what time we're done? What time? Oh, perfect. Now, this says to derive. Because we've put in so much extra time, you shouldn't need to derive them. I want you to write the series for sine. I want you to be 100% sure you know how it starts. You should be able to have 2 ways to think about that. I want you to write the series for cosine, and I want you to put their general terms on there. So I actually am going to pause right here and let you write them out. I'm only going to give you 2 minutes, though. We're sitting pretty. I should be able to finish easily on Thursday while still having time for a quiz. Oh, what? A quiz, I think. No, the quiz is Friday. I misspoke. And again, we can write equals if we're writing the whole series. And I think I'll do e to the x as well. Honestly, I'm going to have to cut you short. I got to cruise. Let's go. Sine, does it start at 1 or 0? Think about it. What's sine of 0? This one starts at 0, right? Which means the next one will be there, which is what? x. Or think sine is an odd function and it has the odd powers. What always comes next for sine and cosine? An alternator. And then we go odd power over odd factorial, alternate odd power over odd factorial plus dot, 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 plus the general term. All right, x to the what? General term. I need odds. How do we get odds? We add 1 to the evens, or subtract 1 from the evens. I like to add. How do we get the evens? We double. So it's 2n plus or 2n minus 1. Could you put either? Yes, but then you'd have to adjust your index. I like 2n plus 1. I don't know why, I just do. That'd be a 2n plus 1. This would be a 2n plus 1 quantity factorial plus ellipses. The most common mistake I just made on purpose. That's the most common mistake with the alternating ones, just in the whole process, forgetting that there's an alternator. Now you have to be careful what index you put on your alternator. If I am going to generate x to the first right here, what am I starting my count at? 0. Okay? If I start my count at 0, is it okay to start my alternator at 0, or do I need to start it? You know what I mean? Will that be okay, or do I need to adjust it? It's fine. This is where when I write the general term, I usually start checking it. I say, okay, if I put in a 0 here, will I get x to the first? And I go check. Yes, that'll go to 1. That'll go to x to the first. That'll go to 1 factorial. Then I plug in a 1 and a 2. I do a double check. But I'd also put a little disclaimer down here showing the reader that I'm starting at 0. Now, could Mary start at 1? Yes. Hers will look different, right? She would have an x to the 2n minus 1 over 2n minus 1 factorial, but also her alternator will change. Are we good with that? So cosine, you could think of it as being the derivative of sine, or the cosine 0 is at 1, so it starts at 0, and it does the even. So I'm going quick here. Let's go ellipse, ellipse, ellipse. X to the what power? 2n. Exactly. Over 2n factorial in quantity plus dot, dot, dot needs the presence of an alternator. Negative 1 to the what? N, as long as my n starts at 0. Yes. I'm not going to write easy. My goal this semester is not to say gonna. I hate it. I always say gonna instead of going to. You should start counting. All right. This is as far as I want to get right now. What's coming? On Thursday, we shall finish. We'll do example 7, 8, 9, and something super cool with deriving Euler's, which is really neat. That Euler's equation's cool. We'll do that on Thursday, and then you'll be able to work on 5A. When is 5A due?